Hello friends, today we will learn elements of symmetry. So let's start to understand elements of symmetry. Elements of symmetry and chirality is mandatory in understanding of the optical isomerism. If we learn to optical isomerism, it is basic requirement to understand chirality and element of symmetry. To show the optical activity, molecule must having a two criteria. First, it having a chiral center and must be asymmetry. First, we learn chiral center. What is chiral center or chiral carbon? A chiral carbon, also known as asymmetric carbon, is a carbon atom which has four different atoms or groups of atom attached to it. Means you have to remember carbon which having a four different atom or group, that is called chiral carbon. In this example, this carbon is a chiral carbon. Why? Because this carbon having a four different group. Here is hydrogen, bromine, chlorine and methyl group. So it having a four different atom or group. So it is a chiral. But in this example, it is not a chiral, it is a achiral because it is having a similar group, hydrogen and hydrogen group. So it is a achiral. In this example, this carbon is a chiral carbon, noted by asterisk sign. It having a hydrogen group, ethyl, propyl and methyl group. This carbon having a four different atom and groups, so it is a chiral carbon. In this example, you can see it does not having a four different groups. That's why it is a chiral. Simply you have to remember for chiral carbon which having a four different groups or atoms, that is called chiral carbon. Asymmetry. To understand asymmetry, in this example, we can see it having a two chiral carbon. Even though it contains a chiral carbon, it is a achiral compound because it having a plane of symmetry, because it is a symmetric compound. So it is a achiral. To understand symmetry or asymmetry, we have to learn in detail elements of symmetry. Now we will learn elements of symmetry. Symmetry is when a shape looks identical to its original shape after being flipped or turned. You can say in this example, this object backside is like a symmetry. It is a backside and it is a side view. So inside view we can say it is a asymmetry. If this object turn into side, so it become a asymmetry. We cannot decide symmetry at a one point. We have to check after flip or turn, is it symmetric or not. So we will going to learn symmetry elements and symmetry operation. Symmetry elements can be understood by line, plane and points. and symmetry operation can understand by rotation, reflection and inversion. These are the different types of symmetry elements and different types of symmetry operations. Axis of symmetry can understand by rotation about the axis through some angle, and plane of symmetry can understand by reflection about the plane. Center of symmetry can understand by inversion. Improper rotation axis can understand by rotation about the axis through some angle followed by reflection in a plane that is perpendicular to rotation axis. We will learn in detail different symmetry elements. So first is the axis of symmetry. An axis around which a rotation by results in molecule indistinguishable from the original. This is also called an n-fold rotation axis and abbreviated by the Cn. Examples are water and CHCl3. This is the example of water. Now what is n-fold? There the rotation is a 360 degree. So there is a one rotation. If rotation 180 degree, so there is a chances of two rotation. If it is a 120 degree, there is a chances of 3 rotation. If it is a 90 degree, so there is a chances of 4 rotation. So we can understand at 361 fold, 182 fold, 123 fold, and at 90 it is a 4 fold. By taking this example, if this object rotated around its axis, it's remain to its original shape. So that is called axis of symmetry. By taking example CH3Cl and water, it rotated around its axis. No change in orientation of structures after rotation because of axis of symmetry. So both compound is achiral, means symmetric. If we take this example, if we rotate this example at 180 degree, so this OH group is transferred to this position and this Cl group is transferred to this position. So it becomes like this compound after rotation. So there is a changes in orientation of structures after rotation. So it does not having a axis of symmetry. So it is a chiral compound. You can say it is a symmetric. Now next is a plane of symmetry. A plane through a molecule that divides the molecule into two parts that are mirror image of each other. By understanding this object, this one part is a mirror image of another part. Similar like by understanding in molecule, you can see this is one molecule, 2-chloropropane. In that 2-chloropropane, it is at the middle there is a one plane. The other part, one part is a mirror to the another part. So it is a symmetric in nature. Here is a CH3 group Also here is a CH3 group. Okay, so it is a symmetry. But in this example, here is a CH3 group and here is a ethyl group. They are not mirror image to each other. One half is not mirror image to other half. So one compound 2-chloropropane is a achiral and 2-chlorobutane is a chiral. By understanding more example, if we taking this example, it having a plane of symmetry at middle. So one part is a mirror image to the other part. So it having a plane of symmetry. By taking this another example, this bromine is arranged opposite side. So it does not having a mirror image to each other. So it is a having a no plane of symmetry. So one compound is achiral and another is a chiral. By taking another example, similarly in this cyclohexane group, both groups are above the plane. And another example of cyclohexane, disubstituted cyclohexane, one group is below the plane and another group is above the plane. So it having a plane of symmetry at a middle. One part is a mirror image to the other part. In this case, does not having a symmetry. So it is one compound is a achiral, another is a chiral. In this disubstituted cyclopropane, both groups are above the plane and another example, one group is below the plane and another group is above the plane. So it having a plane of symmetry at middle. One part is a mirror image to the other part. So one is a achiral and another is a chiral. Simply you have to remember for the plane of symmetry, if substituted groups are on the same side, so it can form a plane of symmetry. So it become a achiral. If substituted groups are opposite to each other, so it does not having a symmetry. So it became a chiral group or chiral compound. Now let's understand inversion center or center of symmetry. A center of symmetry is an imaginary point in the molecule such that if a line is drawn from any group of the molecule to this point and then extending to an equal distance beyond the point, it meets the mirror image of the original group. It is also called inversion. That is also called inversion, denoted by the Ci. So by understanding this example, we have to draw line from opposite group. So we draw line this CH3 and this CH3 by drawing this O and O, by drawing this H group and this H group. So in this example, by drawing a line to the opposite mirror group, it having a center of symmetry. But in this cis example, by drawing a line to the opposite group, it does not having any center of symmetry. So one compound, trans compound become a achiral and cis compound become a chiral. Now next is improper rotation axis or rotation reflection axis. Improper rotation are also called a rotary reflection axis. The rotary reflection operation consists of rotating through an angle 360 degree by n about the axis followed by reflecting in a plane perpendicular to the axis. Just we have to remember in this rotation reflection axis, first we have to rotate a compound at any angle, then we have to reflect at a perpendicular to this axis. By taking this example, this compound is rotated at 90 degree. So it rotated at 90 degree. This group is rotated to this. Okay. And next step is we have to make a plane perpendicular to the axis. Perpendicular to the axis. So it turns to its original shape. It turns to its original shape. So starting orientation and end orientation are same. So we can say it is having a improper rotation axis and it become a achiral compound. Dear friends, thanks for watching.